Resuming on that problem, so the pulley problem part 2, where now I'm going to solve this issue. As you know, we were looking into the initial energy I over here, right? So this is initial part and this is the final energy over here in terms of the kinetic for the first mass, second mass, and the wheel, where v omega r relationship is substituted. And if you realize, I cut off the video a little early, the work is done by non-conservative force here, and that's basically going to oppose the motion. So I would have to put minus sign in here, right? So the total difference in the energy comes out to be, right, final minus initial. I'm choosing this convention because I'm putting minus mgh here. So the difference in the kinetic energy is gonna be half m1 v, sorry, for the second mass it's gonna be m2 v square. For the first mass it's gonna be half m1 v square, right? For the potential energy for the first one, change is zero because it stays on the same level over here. For the second one, as I said, it's going down, so I'm taking minus m2, typo, m2 g times h, right? And that is my net change in the linear kinematic part of, I mean, linear equations there. But I also have the change in rotational kinetic energy, and that's basically half I omega square. So if you realize there, half I omega square, it's gonna be half I omega is v over r, right? So that's gonna be half I v square over r square. That's half I v square over r square equals to minus mu, that is the work done by the non-conservative force. If it was conservative force such as gravity, right, then in that case this part would be zero, but there is a friction, so that's going to be m mu times m1 g times x, and these values are supplied here. All right, now what I want to do is I want to find the value of the velocity, right? So I need to put that alone, so I'm going to collect all the terms that are that contains the velocity in the same place. So that's going to be half, this is m2 m1, right? So I'm going to do m1 plus m2, I undistributed and collect that. There is half plus half and I divided by r square, and there is v square, right? I'm just writing it nicely so that I have v squares nicely aligned. This minus m2gh, I don't need that part on the left hand side, so I'm going to move that to the other side, and that gives me m2 g h minus mu m1 g x. So that is the net work done by the potential energy and the non-conservative force here. So in this case, I have now separated out the v square. I can do v square, right, a common factor here, and I can also take out the half just for simplicity. Okay, v square, and then that's gonna leave me m1 plus m2, right? This first part, v square is out already, half is already out, so that's gonna be that, plus half is out, v square is out, so I'm gonna have I divided by r square as the factor that's remaining, right, equals to m2. If you want, you can take out the g, but I'm not gonna do that. So I'm gonna just basically say m2 g h minus mu m1 g x. Okay, so since you know the mass m1 m2, right, these are known, I is known, r is known, m2 is known, again g is 9.8, h is the height that it fell through, mu is given, right? So I'm going to basically write that as mu equals to 0.3, mu equals to 0.3, x equals to 0.6, right? Okay, and what else do we have? R is given, r equals to 0.05, the moment of inertia I equals to 0.004, kilogram meter square. um, m1 is 3 kilogram, m2 equals to 2 kilogram, right? So you are given all of those and the height. Excuse me. The height is, how high did it fall through? Where is height? Oh yeah, I'm sorry. The whatever distance it travels through this one on the horizontal part, it's gonna be the same height over here. So height is equal to x, which is 0.6 meter. So that's that. Okay, hopefully you can solve it using this. Should give me the velocity, right? So velocity square equals to, I'm gonna just solve this equation here, m2 gh minus mu m1 gx divided by 1 half of m1 plus m2 plus I over r square. Let me see. Now I'm gonna put g equals to 10 just for my, mental math. So that's m2, that's 2 times 10 times the height is 0.6 minus mu is 0.3. M1 is 3, g is 10, x is equals to h, that's 0.6, that is divided by half m1 plus m2, that's 3 plus 2 5, plus I was 0.004, let me get that right, 0.004, okay, divided by r, radius is, wow, 0.05 square. Why can I do that math on my head? Let me see. um, so that's 6, right? Times 2 is 12, minus, that's zero point 0.9, that's 9, 9 times 5.4 basically, right? Because that's point there, and then that is gonna be that 1 by 2 can multiply itself over here. You can do it on your calculator. So that gives me 5 plus, this is basically 0.004 divided by 0 point, that's 25, right? So to 525, so there has to be 2 zeros, so that's gonna be like that, and that's 2340 here, so I'm gonna just do that. So that's almost 2. That's 7, so that's 2 7, that gives me 5.4, that's 6, 6 12, 6.6 times 2 by 7, that is less than 1, right? So let me google that. 6.6 times 2 divided by point, what am I thinking here, 7, it's 1.8 because I did the math over here in the wrong way. Okay, let me just try to correct that. 5 plus 40 divided by 25. I've got 40 divided by 25 equals to 2. What am I doing here? What did I do? 6 times 6.6 times 2 divided by 0.004 divided by 0.05. Now the calculator is giving out square. It's coming out about 2. So, and I used I used 9.8, so there is a lot of approximation happening here. 5 plus, I said 2, so that gave me 1.88, and I think this the value of g is 9.8. So instead of doing 10, if I do 9.8, it should come out about the same value. So if you do that, let me know how that works out. Okay. I think the answer is about 1 point something, 1.4 meter per second. Oh, no, hold on. Okay, let's say that this is 2. Okay, meter per second. I'm sorry. Blah blah blah, right? Haha. Okay, I mean, the calculator was right. I'm sorry. So it came out up 2, right? uh, I'm a bit crazy this morning. So that is 0.004 slash 0.05 square. Okay, that's ah 0.5, Mr. Doctor. Okay, that's 2. Okay, that's right. um why am I defying calculator? That's 2, but this is v square. V square equals to 2, therefore v equals to square root of 2 meter per second, and square root of 2 I know is that 1.4, 1.4326 I think, meter per second. So that's the value of the velocity. Woohoo, I got it.
It's 9 o'clock.
Thank you. um SQRT of 2 is, yeah, 1.42. Okay, 1.42. Of course I'm wrong here. 1.42. Haha, see. Okay, very good. So that's it, guys.